Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Our lesson today is about translation. Now, translation is one of the form of transformation. Let us start by definition. Let V be a given vector. The transformation that associates to every point M the point M prime such that M prime vector equal to V vector is called a translation with vector V. Notation: the translation of vector V is usually denoted by TV vector. Here V vector is written as index of T, and when we see this notation, we mean that we have a translation by vector V. Now geometrically, here we have a vector V, and we have a translation by this vector that transforms M onto M prime. In this case, M prime vector and V vector have same sense, same direction, and same magnitude. That's why we write M prime vector is equal to V vector. Determination: translation of the point M by vector V is equal to M prime if and only if M prime vector is equal to V vector. Pay attention here. M prime vector is equal to V vector. So in order to prove that the translation of the point M by vector V is equal to M prime, try to show that M prime vector is equal to V vector. Elements: a translation has only one element, the vector V. In order to make a translation of a point or an object, we just need a given vector. In the figure at right, we have two triangles ABC and A prime B prime C prime, and we have a vector V. Now translation of the point A by vector V is equal to A prime, since of course vector A prime is equal to vector V. Translation of the point B by vector V is equal to B prime, since BB prime vector is equal to V vector. And by the same way, translation of the point C by vector V is equal to C prime, because CC prime vector is equal to V vector. Thus, the translation of the triangle ABC by vector V is equal to the triangle A prime, B prime, C prime. So as a result, in order to make a translation of a triangle by a given vector, it's enough make a translation of each vertex in this triangle by a given vector. Now remember, translation of the point M by vector V is equal to M prime if and only if M prime vector is equal to V vector. Let us take an example. Let ABC be a direct parallelogram. Let I and J be the respective midpoints of the segment AB and CD. TV vector denotes a translation with vector V. Part 1. Verify that the translation of the point D by vector AB is equal to C, and determine translation of the point C by vector BA. Now, since DC vector is equal to AB vector, then the translation of the point D by vector AB must be the point C. And since CD vector is equal to BA vector, then the translation of the point C by vector BA is the point D. Part 2. Determine the translation of D, J, I, and A by the same vector AI. Since DJ vector is equal to AI vector, then the translation of the point D by vector AI must be the point J. And since JC vector is equal to AI vector, then the translation of the point J by vector AI is the point C. And since IB vector is equal to AI vector, then the translation of the point I by vector AI must be the point B. And since AI vector is equal to AI vector, then the translation of the point A by AI vector is the point I. Now part 3. Determine translation of the point A, translation of the point B, translation of I, and the translation of the point D by the same vector BC. Now since AD vector is equal to BC vector, then the translation of the point A by vector BC is the point D. And since BC vector is equal to BC vector, then the translation of the point B by BC vector is the point C. Now translation of the point I by vector BC. Since IJ vector is equal to BC vector, then the translation of the point I by vector BC must be the point J. Now translation of the point D by vector BC. Here we have to find a vector starting from the point D in such a way this vector is equal to BC vector. So I need to put a point L here in such a way L is symmetric of A with respect to D. In this case, DL vector is equal to AD vector, and AD vector is equal to BC vector. So we conclude that DL vector is equal to BC vector. So the translation of the point D by vector BC must be the point L. Part 4. Find V vector when translation of the point D by vector V is equal to D. In fact, if translation of B by vector V is equal to D, then vector V must be equal BD vector. Part 5. Find the translation that translates J onto A. In fact, it's the translation with vector JA. Now, application 1. Let ABCD be a direct trapezoid with bases AB and CD such that AB equal to CD. Let E be the midpoint of the segment AB. TU vector denotes the translation with vector U. Part 1. Verify that the translation of the point E by vector AE is equal to B. Try to answer it. In fact, EB vector is equal to AE vector, and the translation of the point E by vector AE must be the point B. Part 2. Determine translation of the point B, translation of the point E, and the translation of the point A by the same vector BE. Try to answer it. In fact, BE vector is equal to BE vector, then the translation of the point B by BE vector is the point E. And EA vector is equal to BE vector, then the translation of the point E by vector BE must be the point A. Now, translation of the point A by vector BE. Here we have to find a vector starting from A in such a way this vector is equal to BE vector. So I need to put a point K, which is the symmetric of E with respect to A. In this case, AK vector is equal to EA vector, and EA vector is equal to BE vector. Then we notice that AK vector is equal to BE vector. In this case, the translation of A by the vector BE must be the point K. Part 3. Determine translation of the point B, translation of E, and translation of the point A by vector BC. Try to answer it. In fact, BC vector is equal to BC vector. Then the translation of the point B by BC vector is the point C. And since ED vector is equal to BC vector, then the translation of the point E by BC vector is the point D. Now, translation of the point A by BC vector. Also here we have to find a vector starting from A in such a way this vector is equal to BC vector. So I need to put a point N here in such a way N is symmetric of C with respect to D. In this case, AN vector is equal to ED vector, and ED vector is equal to BC vector. So AN vector is equal to BC vector. Then the translation of the point A by BC vector must be the point N. Part 4. Let M be any point in the plane. Find U vector when translation of the point M by vector U is equal to M. Try to answer it. In fact, if translation of M by vector U is equal to M, then vector U must be equal MM vector, which is equal to 0 vector. Part 5. Find the translation that translates C onto E. Try to answer it. In fact, it's the translation with the vector CE. Remember, T is an identity if and only if T of M is equal to M for all M belong P. B is an invariant point by T if T of B is equal to B. If T of M is equal to M, then T minus 1 of M prime is equal to M. T round T prime of M is equal to T of T prime of M. Properties. Let T V vector be a translation that transforms a point M onto point M prime. The identity of the translation by vector V is the translation by 0 vector because translation of the point M by 0 vector is equal to M for every M. Now for V vector different from 0 vector, translation by vector V does not have an invariant point. The inverse of the translation by vector V is denoted by translation by vector V minus 1, which is equal to the translation by minus V vector. Now, if translation of M by vector V is equal to M prime, then the translation of the point M prime by the vector minus V vector is equal to M. That's because translation of M by vector V is equal to M prime, then M prime vector is equal to V vector. then m prime m vector is equal to minus v vector. So translation of the point m prime by vector minus v vector must be the point m. The composite of the two translations tv vector and tu vector is denoted by tv vector round tu vector. The translation by vector u plus vector v, or translation by vector v plus vector u. Here we have a point m, and you know that the composite of the two translations tv vector and tu vector of the point m is equal to the translation by vector v of the translation by vector u of the point m. And if we suppose the translation by vector u of the point m is equal to m prime, we get translation by vector v of m prime. And also, if we suppose that the translation by the vector v of the point m prime is equal to the point m double prime, we get the point m double prime. Then the composite of the two translations tv vector and tu vector is a translation that takes m onto m double prime directly. Now remember, tv vector be a given translation. Translation by zero vector is the identity. Translation by v vector does not have an invariant point for v vector different from zero vector. The inverse of the translation by vector v is the translation by vector minus v vector. Translation by vector v round the translation by vector u is a translation by u vector plus v vector, or the translation by v vector plus u vector. Example 2. ABC is a given triangle and TV vector is a given translation. Match. Now, translation by zero vector is the identity according to the first remark. Now, the second one, let us analyze between bracket. Here we have translation by vector BC around the translation by vector CA. So, according to the last remark, we get a translation by vector BC plus vector CA. So by justice, we get a translation by BA vector. So the inverse of the translation by vector BA is the translation by vector AB. The third one, translation by vector minus AB vector, of course, is the translation by vector BA. Now translation by AB vector, now the translation by BA vector is a translation by AB vector plus BA vector, which is the translation by AA vector, which is translation by zero vector, so it's the identity. Now the inverse of the translation by AB vector is the translation by BA vector. Here let us analyze between a bracket. Translation by BC vector round the translation by CB vector is a translation by the vector BC plus CB vector, which is the translation by BB vector, which is equal to the translation by zero vector. So the inverse of the translation by zero vector is the identity. Now the last one, let us start by the inverse of the translation by vector AC, which is the translation by vector minus AC. So we have translation, round the translation, round the translation is a translation by the vector AB plus vector BC plus vector CA, which is equal to the translation by vector AA, which is equal to the translation by zero vector. So it's the identity. Now pay attention about these remarks. Application 2. Let ABCD be a given parallelogram and TV vector be a translation with vector V. Part 1. Find the image of the point C by the translation with vector BA. Try to do it. In fact, CD vector is equal to BA vector, then the translation of the point C by BA vector is the point D. Or to find the pre-image antecedent of the point B by the translation with vector DA. Try to do it. Now since CB vector is equal to DA vector, then B is the image of the point C by the vector DA. In this case, C is the pre-image of the point B by vector dA. Part 3. Determine the translation of the point D by 0 vector. Try to do it. In fact, the translation by 0 vector of any point is the point itself, since the translation by 0 vector is the identity, so it maps every point onto itself. Part 4. Find in two different ways translation by vector BC around the translation by vector AB of the point A. Now method 1. In fact, translation by BC vector around the translation by AB vector of the point A is equal to the translation by BC vector of translation by AB vector of the point A, which is equal to the translation by BC vector of the point B, which is equal to C, since BC vector is equal to BC vector. Now method 2. In fact, the translation by the vector BC around the translation by the vector AB is a translation with vector BC plus AB vector according to the last remark, which is equal to AC vector. Then the translation by BC vector around the translation by AB vector of the point A is equal to the point C.